I made a big, pushy, interactive start button for my VR game where you punch things, available now by the way. And in this video, I'll break down exactly how I did it in Unreal Engine 5. And just to avoid confusion, I'm talking specifically about the mechanics of it. The art is really going to depend on you and your own project if you decide to do something similar. Which, who doesn't like a big button? And even if you're not building a VR project, by the way, stick around, you might learn something useful. So first things first, I had to figure out how to get the button to actually push at all. I tried a few different approaches here between physics constraints and traces, and to cut to the chase, the answer is just straight up box tracing. Physics constraints were way too unpredictable. A box trace in Unreal Engine is pretty much what it sounds like. It sweeps a box from point A to point B and tells you if it hits anything. The base logic for a button is actually pretty simple and looks something like this. On tick, we box trace from below the button to above the button, looking for the player hand object. I personally like to use dummy objects, in this case sphere collisions, to set the start and end points of the trace. That way, it's really easy to customize the start and end points by just moving the spheres around. And as a side bonus, you can also use one of the spheres to set the orientation of the box trace. Then, if the trace hits something, we take that Z location and use it for the button. Note, you'll want the origin of the button to be at the top, since that's what gets pushed by the fist. I personally like to use another sphere collision here and make that the parent of the button geometry. And just like that, we have a button that follows our fist vertically when it's within the box trace. However, we don't want the button to follow the hand too far. That would be pretty jarring for the player. So here, we need a relative minimum and relative maximum location to test against. If the trace hits outside of these bounds, we do something else, which we'll get to in just a minute. To get these values, I just sort of manually placed the button where I wanted it for the maximum and minimum and copied those values into Notepad. Nothing special here. However, we do have a tiny problem. The box trace returns a world location, which is what we've been using up until this point. The maximum and minimum we're testing against are relative locations, relative to the actor or whatever you have the button parented to within the actor. And honestly, we want to be setting the relative location of the button anyway. If we set the button's world Z location, like we've been doing so far, it'll only go up and down regardless of how the button is oriented, because it's going up and down within the world. But we want the button to work in any orientation. Specifically, my button is tilted towards the player for ergonomic reasons. So to convert the box trace hit to a relative location, my original method, which worked just fine, albeit a little bit convoluted, was to add another sphere collision and set its world location to the trace hit location on tick. Then I took that sphere's relative Z location and used that for the button. However, while making this video, I discovered we can just use the inverse transform location node instead, and it's a whole lot cleaner. If we grab the actor or parent object world transform and plug in the box trace hit location, we end up with a relative Z location. Set the relative X and Y to what they already were, since we only want the button to move up and down, and we have a technically functional button. But you'll notice the button just sort of stops if we move our hand outside of the trace area or outside of the bounds. Remember earlier when I said we'd do something else here? Well, ideally, we want it to smoothly animate back to its starting position when we're not pressing on it, almost like it's spring-loaded. For this, I like to use an finterp node which smoothly transitions from its current value to a target value over time. A speed of 5 worked well for me, but feel free to experiment here. Now, we also need to make the button actually do something when you press it. Otherwise, what's the point? For this, we can just add a box collision at the base of the button and fire off some logic when it overlaps the button geometry. Obviously, I'm not going to tell you what your button should do, mine starts the game. And finally, there's always some room for polishing. For one, it could be more performant. We don't need to keep box tracing on every tick if our hands aren't even close to the button. To fix this, I put the entire thing within a box collision and used that to toggle a boolean when the fist starts or stops overlapping it. We only run the trace logic if the boolean is currently true. And last but not least, if the player's hand is moving too fast through the button, it won't always trigger or go all the way down. So to fix this, we just set the button to its down position no matter what if the trace hit is ever below the button's minimum relative location. Throw it all together and we have something that works pretty darn well. Then I took all of this and wrapped it in a custom event so I could reuse the logic on my left, right, up and down buttons as well. And that's basically all there is to it. I think it turned out pretty cool, but let me know what you think in the comments down below. If punching things sounds fun to you, do me a favor and check out my game. It's available now on the MetaQuest store. And if you enjoyed the video, make sure you hit that like and subscribe button for more behind the scenes videos and technical breakdowns. Until next time, bye.